Yeah. Hi guys, am I audible? Am I audible to everyone? Please post on the chat. Yes, guys. Good evening. Am I audible to all Zoom and YouTube guys? I'm audible, right? Thank you. So yesterday we had finished with which topic? Will anyone tell me? We finished with the sortings and we had starting with the searching, and we had done a theoretical about the searches, linear and binary. Okay. So let's do a quick program on that today. So I've made a new folder and we'll add a new class in that. Okay, so linear search should be relatively easy for you guys. Okay. So linear search is when you compare the elements one by one. Okay. Till you find the element. So you do a one-on-one comparison. The screen visible to your paint screen visible. I'll just reshare it if in case it is not visible. So I'll reshare my entire screen once again. Yeah. So whenever at whatever point, if you all feel that it's not in sync, now I've shared my paint screen. So if I have an array of size 5 for linear search, the array need not be sorted. You can operate on an unsorted array also for linear search. So randomly I can enter any numbers 10, 50, 40, 30, and then 20. Okay, randomly I'll enter numbers. And these are the indexes. So those are programming, new to programming. For those guys, I do the color coding. Those who have tenured and have done a lot of programming for them, it doesn't matter what color the index is. So now I need to search for a particular number. Let's say I want to search for a number 30. Now, is this 30 there in the array? If it is there, I will say found. If it is not there, I will say not found. So if it is there, I will say found. If it is not there, in this case, I have got the number searching for. So let's say I search for 70. So 70 will be not. So this is what my expected output of the program is. If found, return found. Not there, return not. So what we do in linear search is, yeah, I'll just label it over here. linear search. Okay. So if you're asked for example in an interview as to where we use real-time linear search, so you can see that there's some pickpocket. He has robbed a person, and the victim has lodged a complaint against the pickpocket that he has robbed my bag. So the police, they line up all the pickpockets of that area in the police station. Okay, so let's say we have all these red, green. So these are the different criminals of that area the police has lined up. And the police will now call the victim and will ask the victim to identify who was the person who has robbed him. Okay. So let's say this brown person is the victim. This brown person, he is the victim. So how will he identify the criminal? So he will go and look at one by one. Okay. So let's say the blue one was the criminal. Okay. We'll highlight this, that this person is the criminal over here. But how will he identify it? So he will go and compare one at a time. Is he the one we are searching for? No. Is he the one we are searching for? No. Is he the one we are searching for? Yes. As we get, we will say found, and we will stop our search. We will abort our searching because we have got the element. Okay. And if that person is not in this list, okay, some other person only was there. So let's say if this chap was the pickpocket and he is not in the police station. So this person will check one by one, okay, from the start. So always the searching will start always from the start. So he will come and search, is this the purple one? No. Purple one? No. Purple one? No. Purple one? No. And if he has gone till the end of the list, it is an indication that it is not found. Because had it been found, the search would have broke. Okay, it would break the search. But now as he has reached till the end of the list, okay, so we'll call this as end. So if he has reached till the end, okay, so if I can write this down with regards to the array indexes, so I start the search from 0 index, 1 index, 2 index, 3 index. So if my search reaches till 4, then it is not found, because had I found, I would have terminated the loop in between. So me reaching till the end of the loop is an indication that person is not in this list. Okay. So this is a real-time use case. Okay. You all can also send in your real-time use cases where we can use linear search. So post it on the chat. Okay. This was one example which I felt suitable, so I shared with you all. So now the number which we need to search. Okay. So let's say I'll take the number as n. So in the first case, we'll take n as 30, and this is my ARR. Okay. So I'll hard code the array ARR. I'll say integer ARR. Just reduce the font a little bit. It should be fine. And I'll hard code the values 10, 50, 40, 30, and 20. Okay. And the number which we want to search for, then I will say n equals to first case 30. So my iteration will start from which index? From the start. Okay. So I'll use the I equals to 0, and we'll go till where? In this case, we will go till ARR dot length. and I plus this. And then what will we do? At each iteration, we will compare if we have found the number. So if my n is equal to ARR of I, if it is equal, okay, I'll directly sys out that I have found the number, okay, and I will set the flag variable to 1. So initially we'll set the flag variable to 0. So flag is a variable which you can set and unset at particular condition. So once I get my number, I'll display found, I'll set the flag to 1, and I will break the loop because I don't have to continue searching once I have found the element. And then I'll come outside the loop and check if now I need to check for, okay, what common mistake people do is they put else over here. A very common mistake when linear search people do is they put, if it is matching, it is found, else it is not found. This is a very common mistake people do. Now, what do you think this will lead to? What problem do you think this will cause? So this will cause a problem that if I'm searching for 30, it will first check for what is the value of n. Okay. So if I do a dry run, my I is 0. So my ARR of I will be 10. And my n I'm searching for is 30. So it will compare 30 with n. Is it found? It is not matching. So directly go in else and will print not found. So it will output you. This is the output. So it will output not found. And then when my I will increase, I will become 1. What is my error of I? 50. We'll compare 50 with 30. Is it found? It will say not found. Now I will increase to 2. 40. Comparing with n as 30, will say not found. I will become 3. 30 with 30, it will print found and I will break the loop. So it will display me not found, not found, not found 3 times and then found, which I don't want. So that's why not found should always be displayed after the loop. Do not try to display not found over here. So cut this code from here. Okay. And once you break, and now outside the loop, you can come and check for the value of the flag. So when it was found, the flag was set to 1. So the flag remains. So if the flag remains 0 till the end, you will say not found, and not found we are printing after the loop, so it will display only once. So now if I do the dry run, okay, now if I try to dry run this, I is 0. So ARR of I will be 10. Let's say I'm searching for 40. I'm searching for 40 and n is 40. So is 40 equal to 10? No, it will not go in this if. Okay, I should have closed one more bracket over here. I should have closed one more bracket over here for the if. Will not go in if, then I becomes 1. Okay, and the flag, we need to check that as well. Okay, flag is 0. Flag remains 0. I becomes 1. What is the error of 1? 50. N is 40. Is 50 equal to 40? No. So flag remains 0. Then I becomes 2. What is AR of 2? 40. What is in N? 40. And now both the condition meet. So first I will output found, and I'll set the flag to 1. And I have output found. Okay. And now I'll break the loop. So the loop will terminate over here. Directly I'll go outside the loop and check is the flag equal to 0. No, flag is 1. So this will not display not found. Simple logic of linear search. Now I would want those who have done this, I would want if you all can do this same without using the flag variable. Come on, post in your answers onto the chat. So without using flag, if you all can do it. Okay. Meanwhile, I'll code for the others. Okay. So those who have reached the next level of programming can take this task. So integer ARR, and who can tell me the numbers? The numbers were 10, 50, 40, 30, 20. 10, 50, 40, 30, 20. So they were not sorted. Okay, they were by no means sorted. So are just random numbers. And the first case wherein the number I'm searching for is there in the list. So let's say I've searched for 70. You all can also try that it has found and found at which index. So try to add flavors to the program. So I'll take the flag also, set it to 0. You can use the flag as boolean also, but I prefer integer flags. And now let's try the loop. I equals to 0, I less than ARR dot length, and I plus plus. And we will then check if any element at I index matches with the in. If it does match, first thing first, set the flag to 1, sys out found, and then break. And then outside the loop, if you go outside the loop, and check if the flag value is still 0, then you can sys out not. This is the basic implementation of linear search. Right click, run as Java application. So 70 is found. If I search for 90, 90 is not there in the list, should display me not found. Okay. One case. Now, second case, if I want, this is a basic program. Okay. So if I want to do this without the, yes, flag is a variable, Harshita. So flag is a variable which we can set and unset at any particular condition. Okay. It has a Boolean sort of value, like 0 and 1 only it has binary values. So if I'm using an integer flag, we'll have 0 and 1. We are using a Boolean flag, then it will have only true or false. That's the only value the flag variable will have. And based on any particular condition, you can set or unset the flag. I am setting the flag when the element is found. Okay. Very good. You can ask in your doubts, guys, on the chat. I'll be more happy to help you all. Okay, so has anyone done the program in which we don't need the flag variable and we can do this without the flag? Let me switch to the YouTube and check. Am I audible to you all? YouTube guys? Where are they today? This bunch is very active most of the time. Show your presence, guys. Am I audible to you all? So who's coding this linear search without using flag? Anyone's trying? From the online guys? I hope I'm audible clearly to everyone over there. it's up to you, Suhani. You can implement programming in various ways. So this is the simplest programming like logic which I implemented using linear search. So you can, as per your understanding, you can. Yes, yes. If you have tried, please post it on the chat. So those who have tried this, solving this, cracking this code without flag can also do so. Similarly, when the Zoom guys can share their code onto the chat and ask their queries onto the chat. I'll give her 2 minutes, then else I'll disclose the answer. दुआ करो बोला दुआ दुआ करो ठीक है हाँ तेरा ऑनलाइन नेट नेट लगा कर ठीक है मत आता फोन कर लूंगा फिर मत मैंने बोल फिर मत करूंगा Yes, so I've got a decent amount of responses. Okay, now let me try to implement it. Okay, so maybe I'll copy this code and paste it again so that you all have all the flavors. So whatever code I'm doing, I'm not deleting or overwriting. I'm just writing new classes. So now I'm into the linear search part 2. I'm audible to you all the rest, guys. So now what we can do is now instead of using this flag, you can eliminate this flag variable. And as I said, when is it not found? So if while searching, we reach till, so 0 index, 1 index, 2 index, 3 index, 4 index. If we have reached till 5 index, means it is not found, because if it was found, I am breaking in between. So if the loop has not hit break and the loop has naturally died, its death by reaching till the end, means the number was not there. So directly you can check over here. If my I has reached till the length, so if my I has reached till the, okay, so for that reason we'll have to declare the I outside because its scope is only within. Okay, so here. Okay, so if my I has reached till the end, if this loop has died its natural death, because if I find the limits, I'm breaking the loop at the very moment. So if I don't break this loop and the loop dies naturally, when will the loop die naturally? When I will be equal to length, because till it is less than length, the loop will iterate. So if my I is equal to length, I will say not found. So I've reduced the, so let's try to search for 90 and it should say 90 is not found. Let's search for 20. Let's search for 20 and it says 20 is found. Make sense? So this works in linear time complexity. So we'll go on comparing each. So if I am searching for 10, will be compared in one step. If I search for 20, will take 5 comparisons. Okay. So let me show that also. Okay. And the optimized way of writing such code is always try to use functions to write this code. Okay. So let's try to use functions. So let's copy and paste this and make a linear search 3. So whatever business logic you need to write, always try to write that using functions. Okay. So let's call a function linear search. This will be a good practice. If you're asked to write a program and they ask you to share your screen, wherever possible, try to use function. So you're trying to say, I've got the data from where I need to search and what I need to search. So I write a function and always write function in camel case. Always write function in camel case. The first letter should be small and then the first character of every forthcoming word should be capital. That is camel case. And now I write the logic over here. Okay. So I take I and yeah, this is still appreciated. So let's try to run this code and check if it works. You can still keep on improving this. So it says that you have passed 20 and 20 is found. If I pass 22, I pass 22, it says 22 is not. This is also X very good. Now still we can see. So this is searching also and displaying also. Both the job is done by the same function. One function should do ideally one job only. So linear search's job is to tell us whether the function is number is there or not. To display, we'll ask the main function to display it, the caller to display it. So let's try to write it even better way. So let's try to. What happened? Did I paste it somewhere? Okay, I pasted the code over here. Should I copy pasted the file? Okay. So now let's try to even do it in a better way. So I'm calling the linear search function. Okay. And then I will, if it returns me an integer value, integer result. Okay. So it will return me the index at which number. So I will say if it is found, if it is found, it will return me the index. Okay. And if it is not found, it will return me -1. So I'll say if result is equal to -1, sys out not found, else. Okay, so as it is a one single statement. Else you can say found at index, found at index, and which index? The result. And now what will we do? Once we break over here, this will now return an integer, right? Because on the LHS I have an integer variable. So this will return a integer. And once we find, directly we will say over here, will not display over here, right? We will return I. So this will return from the function. And if it doesn't hit this return, then we will say return -1. So see, what we're trying to do, search. So now we can take this I over here. So now we need to write extra code. So now what are we doing? Starting from the 0 index, searching till the end. If at any particular point of time I get the value, I will directly return that I. Okay. So that I can be 0, 1, 2, 3, 4. If I do not find the number, means this loop dies its natural death. If the loop dies its natural death, I will return -1. So if his result is -1, means the number is not found. So now this is looking the best of all the codes. So whatever. So if the examiner gives the same question four guys and says linear search, so the eyes will lit up. Okay, it's like a batsman getting a full toss delivery. So whenever a batsman gets a full toss, I know try to he takes it as an opportunity that I've got opportunity to score a sixer. The very easy delivery has been balled by the bowler. But the examiner would not just want to see the output. Okay. The examiner would not only just would want to see the output, rather the examiner would also want to see your coding style also. So if candidate one codes like this, runs the code runs perfect. Candidate two codes like this, code is perfect, output is perfect. Candidate three codes like this, perfect. But candidate four, see, you see the style, yourself, you will see the difference. Okay. See, the brand is different, the finishing is different. Okay, so this is what we are expected to do. So this is what is the target of these sessions, that you become accustomed to writing cleaner code and less code. So see, this simple four lines have we've achieved this. So this is what should be your target, and this is what you should take away from these courses. So never get excited by just looking at the question that it is easy, but try to solve it in the best possible manner and the most readable manner. So functions are always good. Functions are always good in this regards. Okay, let's run this and check whether you get the desired output. So 22, is it in the list? So it should say not found. Not found. And is 70 there in the list? Let's run this and check. It should say found at index 3. See, isn't this looking much more better? Found at index 3. So now I will give you all time in between and ask you all to code. Okay. So take 5 minutes and try to code this. I push this code to the GitHub, so you all can have access to the code. So you all can also have access to the code. You all can to the GitHub repository, and you will get all the code what I'm doing today. So once I finish my code, I will push it to GitHub. Today is day 4. Yes, guys, I pushed my code to GitHub. I have shared the repository link with you all, right? I'll refresh it and try to fetch it from there. Try to use it as a reference point. Try to use it as a reference point. I'll share it across both. Okay. Yes, Lakshman, good one. Correct. Perfect. Yes, also is going pretty well. Perfect. Okay, so try to use functions wherever possible, right? Online guys, all good. This, what do you call Zoom guys? I've shared in the repository. Now take 2-3 minutes and try to code this with whichever version you feel comfortable with. Okay, not insist any particular style. Have suits you. You can adopt that. Okay, writing functions would naturally help you all, and instead of we can use return. So return will break the loop so and on the function also. So return will do two tasks. It will break the loop also, and it will also break the function. Directly will return to the caller. So if any index matches, directly we return to the caller and we that access to OE. Okay. Now, can anyone also improve this? Can anyone also improve this now? Have you all heard of ternary operator, question mark, colon? Have you all heard of this operator, question mark, colon? It is called as ternary operator. Okay, first you all code this. First you all code this. Let's try to go slow and steady. I'll not rush. We are the first week. So let's try to go slow and steady first. And once you all code, you all can push your code onto the chat and you all can share it with me. I would appreciate if even the Zoom guys would be involved in the discussion. A handful of YouTube guys are pretty much visible and participating in the discussion. And I see they are benefiting from the sessions. So let's check who sent the response. Yes, yes. So now try using the ternary operator to display the output instead of if else. Okay, so yes, these guys are showing interest. So I'll also. So let me give you all time to practice in between. Okay, 5 minutes up. So now I'll explain what is a ternary operator. This also would impress the examiner a great deal if you can use ternary operator to replace your traditional if else. Okay. See, if else is very verbose, very lengthy sort of programming. There was a debate that Python is catching up with Java and people are transiting to Python because the code in Python is very short. So Java has taken a leaf out of Python's book and has implemented all those concepts in Java also. So the lengthier code has been shortened. So if I have to find maximum of two numbers, let's say I say A is 100 and B is 50. So which number is maximum? I want to display that. So traditionally what we would do, we would say if A is greater than or equal to B, or we would say if A is greater than B, okay, we will this out maximum number is A, right? And else we would sys out or SOP in Java. Maximum number is B, right? This would be such a lengthy code. So this code is shortened. Okay, so this part we will need because we need the variables. This code is shortened by using a ternary operator, which we call as conditional operator. Okay, and it looks like this, question mark and colon. It looks like this. Now, how to use this? Very simple. First, check for a condition. Okay, let's say I just give this simple. Okay, so if this condition is true, put a question mark. So this I'm checking for a condition. And a condition, you will know from your basic programming days that a condition will always have two outcomes, either true or false. So condition like a coin has two outcomes. So if you check any condition will give you two outcomes. Either it will be true, so you need to check what we need to do if the condition is true, or that condition will be false, right? Either of them. Just give me a minute. I'll be back in some time. Just give me a minute. Yes, guys, I am back. Okay. Is my paint skin not visible, guys? Thanks, guys, for bringing up. Thanks for highlighting this. Vignesh, thank. Now it's visible, Vignesh? Okay, thanks. So a condition will always have two outcomes, either true or either false. So if it is true, what we need to do? So we can decide what step we need to do if it is true. So here in this case, I check for the condition. If it was true, I did this, right? So we need to decide for some number steps which we need to do when the condition is true, and some steps we need to decide when the condition becomes false. So over here I have written else in the case condition becomes false. And then program continues execution. So they both get merged back. Okay, so they both get merged back again into one common point, and then code continues execution because it is a condition, not a iteration. Iteration goes. One second, guys, I'll be back. Just give me a minute. And then the code continues execution because in a conditional statement it is only one, and this continues. Okay, so here we check for a condition in a ternary operator. So we check for whatever condition you want to check. So here we are checking for this condition. I'll mark it in red over here. This is the condition you're checking. So here too also I'm checking for a condition. Now this condition can either be true or false. So if it is true, I'm executing this instruction. And if it is false, I'm executing this instruction. So same way over here also, check for the condition. If it is true, then we execute the instruction between the question mark, and we have to put a colon also. So the instruction between the question mark and the colon will be executed. And if it is false, then the instruction between the colon and semicolon will be executed like this. So check for this condition. Okay. Check for the condition. If the condition is true, execute the code between the question mark and the colon. And if the condition is false, execute the code between the colon and the semicolon. And you can store that in the left hand side variable. So if I take an integer z over here, okay, I'll take an integer z. So this will complete the sentence. So check for a condition. If it is true, A will go into Z. If it is false, then B will go into Z. Like this. This is a simple statement. Check for this condition. If this condition becomes true, the code between the question mark and colon goes in the left-hand side variable. And if it is false, the code between colon and semicolon goes in the left-hand side variable. So now this lengthy 5 to 6 lines of code has been shrunk into just one single line of code by using ternary operator. So I have to show you all over here with programming. I am able to see the programming screen. So let me show you all over here. Class, okay. Ternary operator. And now I'll say integer A is 10, integer B is 20, and I'll just say integer Z equals to check for the condition A greater than B. Check for this condition. Okay. If this condition is true, A. If it is false, B will go into Z. And I will sys out the Z. I will say maximum number is Z. So in one line, I have done the multiple if else. So right click, run as Java application, and or 10 and 20, maximum number is 20. If I make it 120, the same code you will see will run, maximum number is 100. Okay. So you can write this, or you can also try to eliminate this. You can directly print it. So directly you can come over here. Okay. And now I'm trying to go a bit deeper. Okay. So try to be with me. I'll just copy this and paste it so that you understand. I'm going to turn on operator 2. Okay. So I've got A and B. And now what I'm trying to do is we will just check for the condition over here. Okay. So we will just put this over here. Okay. So we'll try to take this and convert this. Okay. So we'll check for this A greater than B. Check for the condition. Now I've switched to my programming screen. Is the programming screen visible now? I had explained the all over here. This was visible. Everybody got this. Okay, this everything understood. Then I switched to my programming screen and I explained you all with the first example like this. Yes, Vignesh. So I took two numbers A and B and checked for A greater than B. So if this condition is true, this part will go in the LHS. If it is false, this part will go in the LHS. Okay. And I ran the code and showed you. Run as Java application. So out of 120, 100 is maximum. If I make this as 200, 200 is maximum. Okay, so I'm doing this using ternary operator. And now the next level what I showed was still in paint. No, I am seeing the Eclipse over here. Let me check the zoom, guys. Was my screen frozen, guys? Now what do you see, Vignesh? Okay. Now to do it even more faster, if you want, we can do it in one line also. Take A and B and then check over here. If A greater than B, question mark, colon, else. So if A is greater than this condition is true, A, else B, maximum number is. So let's try to run this code and check. Right click, run as Java application. See over here, maximum number is 100. In one line, I have calculated and displayed everything. So this is called as a ternary operator. So can we implement ternary operator over here? We have a if else. So can anybody try to implement this using ternary operator? Send it to me across the chat. Anybody? Let me check if the YouTube guys have done it. Okay. Yes, now you're doing it in one single sentence without taking it in the message variable, directly displaying it. Now you're storing the answer in a message and then displaying the message, right? So now you will sys out the message, no? Yeah. So can you just do it in one? Yeah. Sort of. Still, Lakshman, you are taking in the, yeah, Lakshman is also doing the same thing which Yes has done. You all are storing it into a variable, no? Yeah, yes, try to improvise and try to improve. See, the YouTube guys are performing pretty well. I'm constantly switching between them. Maybe they are interacting more, or maybe they might be mutual students who are joined using both. So now let's try to implement this linear search using, now here we can use the ternary operator. Okay. So what will we do now? So first let's do it by the basic thing. So we'll output this into a string. Okay. So we'll output this into a string. Okay. So we'll say string display, what we need to display. And what will we do? Check for this condition. If it is equal, if it is true, what will I display? Not found. And if it is false, what will I display? Found address. So I'll comment this out. And now I will just sys out the display. Yes. This is what you guys have done. I will sys out the display. Okay. So this is my linear search file. So I click run as Java application and 70 is found at index 3. 78 is not found, right? But still here we are doing 2 lines. So I want this to be in one single line. Okay, so and you see now the code is in the code becoming more short, guys. Okay, so what Python can do, Java can do equally. And now Java is at the top of the we'll confirm it with chat GPT also. I'll show you. Now let's try to make it more faster. So linear search 6. So now I do not want this to be stored in a variable and then display. So directly what we can do, we can directly take this out and put it directly over here. Okay, see. So if result equals to 1, what to display, not found, else found at index. And now we'll run the code 78. If I run, will give me not found. If I run for 50, will give me that. Okay. Can anybody do it even more faster now? See, this function call is giving me the result, right? So can't we not just replace this function call now? Let's go level 7. So can't we just replace this function call over here? Can't we just replace the function call over there? Can't we just replace the function call that I'm doing a linear search on this number? If it gives me -1, I will say not found, else I'll say found. Okay, but now where are we going to store the index? Yeah, that will be a problem now. Now, from where will you get the result? So this would be a good thing if you want to. Now you have to display the index also, no? So maybe yes. So we have to store the index. Had it been about only found and not found, this would have worked. Had it been about found and not found, this would have worked perfectly. Had it been about found and not found, see, 50 is found and 55 is not found. Had it been only about that, it would have worked. But now as we also have to store the index, and that index, this function is returning, right? So that for the purpose, we have to then store the result. So we'll have to do this. Yes. Had it not been about the index, no, then only in one single line, you all could have done it. Okay, guys. So 6 and 7 is looking more or less the same, right? So I'll just put it over here and say, and we'll have only found and not found option. If you want to use 7, this will only be found and not found. Okay. So like this, we can try to shrink the code and it is working fine. Okay, good one. I hope all have done and my skin is visible and I'm very much audible to everyone. All are understanding the concept. Okay, so out of this, wherever you wish to draw the line, you can draw for yourself. Okay, and if you can reach till level number 7, that would be ideal scenario. Okay, so that will come with practice. The more you practice, the more you'll improve in your programming skills. So you should practice. Okay, so when we visit the one element at a time in an array, that is your linear sort of traversal of an array. So if I ask you all, can you all display me the square of each number in an array? Take an array and display me the square of each number. So how will we do that? So we'll have to go one number at a time, right? Once I'll take 10, I'll square 10. Then I'll take 50, I'll square. Then square 40 and square 70 and square 2. And display the squares. Okay, so let's try to do that. So I'll make a new class. display squares of numbers from array. Okay, let's take the array. Let's take 5, 9, 3, 6, 2. Now I want to display the squares of each number. So when we traverse the array, is into linear time complexity. Okay, a linear search has a time complexity of O of n. How will you do that now? So either you can do using the traditional for loop, len and I plus plus, and what will we do then? So now we will, if you want to directly display, you can just display it like this. AR of I into AR of I. Directly you can display it like this also if you wish to. Okay. This is pretty elementary, right? Okay, can you all do one thing? Can you all store numbers in an array and display me those numbers which are perfect square? Can you all store 5 numbers in an array? Okay, I'll write the question down over here. From an array, display the perfect squares. So those numbers will form perfect square. 25 is a perfect square, 5 square 25, 3 square 9, 13 doesn't form a perfect square, 16 4 square, 29 doesn't form a perfect square. So output of this array should be 25, 9 and 16 are perfect squares. So you should say perfect squares and you say 25, 9, 16. Can anyone try? I'll give you all 5 minutes. Come on, try. And then I'll program it. I hope it's visible to everybody. So this also will be in linear time complexity because you have to visit one at a time and check and display. Okay, so these are all linear time complexity programming problems wherein you have to visit one at a time from start till the end. So this is all based on linear search phenomena. So try. If I try to remove the square root of 13, what will be the square root of 13? If I try to this, I fidgeted with this array. I have to change the class name, display perfect squares. If you, whenever you change the name of the class, first save it and hover the mouse over there, it will ask you to rename. Just rename it, it will rename over here. If I comment this out, and if I just want to check what is the square root of 13. So I have a math.sqrt function. And you can check. So let's check what is the square root of 13. Should be between 3 and 4. It is 3.6. And if you want to eliminate the decimal point, okay, you can convert this into an integer value like this. Let's say into an integer n. You can typecast it like this. Okay, so it converts the value into a integer. Transform void. Okay, I am printing. No, I should not have printed. So you can do like this. So math dot square root, whatever it is, convert into an integer. So integer will truncate all the decimal points. So we'll give you only 3. I say out 3, what will be the answer? If I say out n, answer will be 3. Right? So it truncates all the. So I'm giving you all a hint. Try doing it now. I've given you all a hint. Simple question. Should be good for you guys for practice. So accept 5 numbers in an array and display me all the perfect squares. And the hint I have given you all over here. Let's see who takes up the challenge and tries to solve it. I'm randomly switching between. That logic you're applying for perfect square, yes? I equal to 1, I less than n by 2, I plus plus. Where's Junaid today? Junaid is not silent today. Has he not joined? N mod with I equal to I. But that is an iteration, no? So how many times will you display perfect square, perfect square, perfect square? I is an iteration, right? So your I will iterate 5 times, let's say. If the number is 10, you're going from 1 to less than 10 by 2, 1 to 5, 1 to less than 5, 1, 2, 3, 4. So loop will run 4 times. So 4 times will you, yeah, so she tried to refactor it and check. So question is pretty straightforward and pretty interesting also. Should be interesting for you guys to attempt this. Yeah.
Yes, students, there is some network disturbance. So let's wait for some time. Sir will reach me.
Yes, guys, try to solve. So let me try. Let me know once what do you all see on my screen? Do you all see the coding screen or do you all see the paint screen? Yes, guys. Zoom guys can reply, but I'm not switching to the YouTube. Yes. Okay, right? Okay, Vinesh. So now let's take an array of size 5. Okay, so what did we take? We took 25, 9, 13, 16, and let's say 21. So out of them, which are the perfect squares? So, so either you can iterate via traditional for loop or via the enhanced for loop. So what enhanced for loop does, you all know, right? We had that in the first session. It will take one number from the array and put it into n. So what is in n right now? Right now n has 25. Okay. So let me find the square root of this n. I'll call it as sq. So how do I find that? Math.sqrt of n. So convert it into an integer type class. So now what is in? So if my n is 25, what is in sq? Let's do the dry run over here. If my n is 25, then what is in the sq? Sq is 5, correct? You can, and then I will check and I will say if my sq into sq gives me the number back, then I will tell it is a, as only one single statement is there, so I will just sys out. I'll sys out n. See, simple. Okay. So let's try to code with this. Okay. So first, in my first iteration, n is 25. I find the square root of n, which is 5. So what do I check? sq into sq, that is, okay. What will you check? What is sq into sq? 5 into 5 is 25. Is this sq into sq same as n? Yes, it is. Display the n. So this is my output. So our output 25. And then loop finishes. I take the next variable in n. What is in n now? N is 9. What is the square root of n? Convert to integer, okay? Convert it to an integer. So it will be 3. Then what is this? What is sq into sq? What is 3 into 3? 9. Is sq into sq same as n? Yes. So I will display 9 also. Coming to 13. Okay, coming to 13 now. So what will be in sq? So as we said, square root of 9 is 3 and then 16 is 4. So whatever is between 9 and 16 will have 3 point something. So it will have something 3 point, let's say 3.5, let's say. Convert it to a decimal, will only be left with 3, correct? So what will be in sq now? Sq will be 3. And what is 3 into 3? 3 into 3 is 9. Is 9 equal to 13? No. So this number will not be displayed. It will be skipped. It is the logic, guys. And then when I take 16, what is the square of 16? 4. Sq into sq, 16. Is this square root similar to n? Yes. So display the n 16. And the next number is 21. So 21 lies between which perfect squares? 16 and 25. So 16 square is 4, 25 square is 5. So 21 should be between 4 and 5 something. Let's say 4.5. Convert it to an integer. What will come into SQ? SQ will have 5. SQ will have 4 rather, right? SQ will have 4. Then SQ to SQ, 16. Is 16 equal to 21? No. And it will show not. So if I save this and try to run this code, run as Java application, will only display with the perfect squares. These are all examples of linear searches. You just traverse the array one by one and do some operations on that. So checking whether the basic questions. So should be a good practice for you guys for the interview room. Let me push all this code to the GitHub. So I'm just pushing all the code, whatever I've done. Okay. So like this, you all can practice. Okay. So if more questions on arrays, if I have to ask, okay, for you guys to get engaged into programming. So let's take a question. Okay. So yeah, I'll just, is my paint skin visible? Please let me know. Is it visible? So if in an array, I store the daily collection of a shopkeeper. How much- My paint is visible to you all guys, paint screen. Okay, Vinesh, thank you. So let's say this his weekly collection I store. So this is the array of size 1, 2, 3, 4, 5, 6, 7. Okay. So these are his collections for the 7 days his shop is open. So let's say on the Monday he has collected 100 rupees. On Tuesday business was good, 500 rupees. Wednesday business was okay, 400. Then Thursday was very good. Then this, then weekend was also nice, 500, and let's say 600. So he has some targets to achieve. Okay, let's say if he has 3 targets. Let's say he has 3 targets. Okay, so I will ask him to enter the number of targets. First, we can hard code the target. Let's say he has 3 targets. So let's say we'll ask him to enter his target 1. So if he enters his target 1 as 1000, so my output should be on which day did he reach that target? On which day did he reach target 1000? Who will tell me? Yeah, I'll index the arrays. So you can give me the index if you want. If not the day, you can give me the index. On which index did he reach that target? So 1,100. Then by Tuesday he had 600. Then on index 2. Okay, so if I say 1,000, you should say on index 2, or you can say on day 3, whatever you feel comfortable. Then we will ask for the next target 2, and let's say if he enters target 2 as 2,000. So on which day did he touch 2,000? 100, 600, 1,000, 1,700, 1,900 on index 5. On index 5, that is on day 6. And if I give a target, okay, which is not achieved, you should say that also. So get target 5,000. So you should say target not achieved. This is my question. Understood to everyone? Pretty self-explanatory question, not tricky at all. So here also we will work on linear time complexity. But one by one, we will be traversing the array from the start. And where we get the target, we will stop, right? So sort of a linear search example. So where we get the data, we will stop, we will not go ahead. Again, start from the start, where we get the data, where we reach the target, we will stop and not go ahead. Okay. So such questions, they will formulate in a word problem and show it to you. So they will try to be a bit more intimidating and threatening. Okay, they will try to make a word problem. A shopkeeper does business for 7 days a week, store the daily collection of the shopkeeper into an array. Calculate on which day the shopkeeper achieves the target. Like this, they will give you in a bit more sophisticated way. I have tried to explain a very easy way. Now try solving this. Not try. Okay. I'll give you all 5-7 minutes and you can try it. The question is in front of you. And if anybody is struggling with the question, can ask me. I'll explain. Okay. So let me flip to the YouTube guys and check what they are doing. Understood, right, guys? Online guys, I've understood the question, right? Anybody needs any clarity in the question? So try now. Everybody understood the question, right? So try solving it. Come on. This is the question. Once you all attempt, then I'll try it. I'll give you all 5 minutes to solve it. It's a bit more complex question, so I'll give you all 5 minutes to solve. So expect questions of such intensity, guys. Anybody wants clarity in the question can ask me. Okay, I'll store this also and save it in your by doing it. Okay, so should I start or do you all want more time to solve? Yes, guys. Should I start solving the question or attempting and you all more time? Okay, so I'm able to see my coding screen or the paint screen now. Yes, Vignesh. कौन सा shopkeeper targets? What see the screen now? Is my coding screen visible to all? Or still is it reflecting the paint screen? So let me take his business days. Visible, right? My switch to my coding screen visible to all? Okay. So let me start. So let me take his collection in an array. So what was the collection? 100, 500, 400, 500, 400, 700, 200, 500, 600. 1 second. No, give me a minute. It's like I'm back. So I'm able to see the screen, right? And now we have number of targets. So he has to achieve 3 targets. So now what will we do? So we'll run a for loop. I equals to 1. I less than equal to 3. Not 3. I less than equal to number of targets. And I plus plus. Okay. And we'll take an integer sum equals to 0. And now we will iterate this array from start to end. For I equals to 0, I less than arr dot length, and I plus plus. Okay. So first we'll ask him to the target which he wants to achieve. First target. So here I will be requiring scanner now. Control Shift O. So I'll say sys out. Enter. Target number 1. So I'll say enter target number percentage I. So I'll say enter target number 1. They will enter the target. So let me take it to target. His first target. What is his first target? 1000. The target now has 1000. I will keep on finding the sum of the array till we reach this target. Okay. Why is displaying an error? So we have two local variables. Guys, just give me a minute, I'll be back. Okay, so we'll start. Okay, so we have two local variables I, right? So we'll call this as J then. There should be no conflict. So you're able to see my coding screen, right? So J equal to 0. And then now what will I do? I have initialized sum to 0. So what will I do? I'll add the sum, the value of J. So what is now my J? J is 0. So what is the value of 0? 100. 100 will go in sum. Then I'll add 500, 400. Till when will I keep on adding it? I will keep on. So I'll check for condition. If my sum becomes greater than or equal to my target, then I will stop. And then I will just directly say sys out. Target has been achieved. Target achieved. on. Okay, so I'll say index. You all can modify it to day. And who has the index? Index is with J. Okay, on index J. And then no need to search ahead. We'll break the loop. Okay, we'll break the loop. We'll break this for loop. And now this will increment. We'll take the next target. I'll ask enter the next target. Target will be 2000. Again, I'll initialize sum to 0. Again, start from the 0 element, iterate to the entire length of the array. Keep on adding each number into the sum. And after adding, check for whether the sum has increased the target. If at any position the sum is become greater than or equal to target, I will say target achieved and I'll break. Okay. So let's check if this works. Okay. We also have to check for target not achieved. As of now, I have not checked for that. I have just checked for target achieved. I'll just go Control Shift F will format this code. I am a much big fan of writing these loops underneath. It's become more readable for me. I try to write it like this. It makes it more readable for me. You can use whatever style you all want to. Let's check if it is saying. So I'll enter target run as Java application. So target 1000 achieved on index 2. Is it so? Is it so? Achieved on index 2. Yes, correct. Okay. Then again I'll run it. In the second target 2000 achieved on index 5. And now I haven't checked for 5000. So it will not show anything. So instead it should have shown. Now what modification do I do in this code to accommodate that? Will tell me. So I would normally go with the flag. It becomes easier for me. Okay, so at every iteration, I make a flag. Okay, and set it to 0. Whenever the target is achieved, I'll set the flag to 1. So whenever the target is achieved, I'll set the flag to 1. Okay, and then we can come and check after the for loop. So we are breaking, right? If the flag still remains 0, then we will say sorry, target not achieved. Yes. Sorry, target not achieved. Okay, so I'll do a save. And now let's run and check. Run as Java application. First target 1000 on day 2, 2000 on index 5, and 5000. Say sorry, target not achieved. Okay. So try completing this code now and see if you can look for any areas of improvement and any areas of enhancement. Okay. One, we can argue that we can remove the flag variable and we can compare the value of J with the array length. Okay. But to make it simpler, I'm using this. This becomes more simpler. Okay. Just set the flag to 1 and check the value of the flag. So this becomes more simpler. So I have shared you all the attendance link. You can mark your attendance. And I'm freezing this screen. Let me push all this code also onto the GitHub. So now try solving it. I've frozen the screen. Push the codes. You all can also mark your attendance and try to complete this code. If anybody is struggling, can ask your doubts and queries. I've shared this code over here. Okay. Let me check on the YouTube page. What are they doing? Yes. Yes. Are you able to get the output? Others? Time. Try posting your code onto the chat. If you are trying, post that also. So in progress. Okay, so you all can say in progress, or you can share the whoever is trying to attempt this. Now I want to take the number of target from the user, I can take it and then iterate this loop that many times. Okay, that would not make much of a difference. So that would just be one scanner. Tomorrow I'll start with binary search, and we'll take search real-time scenarios and where we can implement binary searching. So meanwhile, you'll complete this code. I'll just check on the GitHub if everything is published properly. Try to solve such more questions on your searchings, sortings. Okay. Any areas of improvement, if anybody can suggest over here, we can try to implement that also. What if I wanted on which day did we solve? If I wanted to implement on which day did we achieve the target? So we can have generally change over here on day and year. We will just have to write J+1. So that would show us on which day the target was achieved. Let's run this and check. Okay. So if I can say over here day 1, 2, 3, 4, 5, 6, and 7. So total revenue, but till day 1 was 100. Till day 2 was 600. Day 3 was 1000, 1700, 1900, 2400, 3000. Right? 100, 600, 10, 1000, 17, 19, 24, 24, 6. Yeah. So now let's me try to hit the target 1000. Which day? Day 3. Target 2500. 2500 was achieved on day 7. Yes. And target 3100. Target not. One second. This code, I'll be back. Yeah, just Yeah. Otherwise also we have done. Let me push this code changes. Yeah, please mark your attendance, guys. Then I shared the link with you all. Mark it. Yes, so guys have solved. Suhani, Namrata, Yash. Perfect. And I've got the answer, right? Everybody? And the Zoom also, I hope people have attempted on the Zoom also. And we can think of any other faster logic. You can implement that also and post it onto the chat after implementation. I have posted all the diagrams also, whatever we have drawn. I also have posted onto the GitHub. Okay, Amar sir, then we can call off for today.
Yeah, sure, sir. Thank you. So, dear students, I shared the attendance link. I hope everybody mark. If not, I'm sharing that once again. So please mark your attendance and share your valuable feedback. Zoom and YouTube both participants. And we'll see you on tomorrow, sharp at 7 o'clock. So till the time, take care of yourself, take care of your family, and goodbye.